This is a quick demo of how to find eigenvectors and eigenvalues in Python. So in the first cell, you can see that this is how we create a matrix variable. First, we import numpy as numpy. Then we are creating a matrix. A is equal to numpy.array. Then each row as a list. So this creates a 2 by 2 matrix. When we do shift enter from this cell, this matrix is created in my memory. As you can see, I can type A here and do shift enter. That matrix is fed into my memory. Then if you want to calculate eigenvalues and eigenvectors, we have to import another module within numpy, and it is called linear algebra, linalg. So linalg is a sub-module which is has the functionality of eigenvalues and eigenvectors. The reference is here. You can check out if you want. So we include linalg as LA variable as a handle for that. And if you want to calculate eigenvalues and eigenvectors for a given matrix, then this is the command. The output is a pair tuple. Eigenvalues and eigenvectors is equal to LA linalg module dot eig. So LA is the module and it has a sub function called eig. And that function takes an argument to the matrix that we have created. Okay, so if I do shift enter from here, this particular line calculates the eigenvalues and eigenvectors of the matrix A and stores the value of eigenvalues here and stores the values of eigenvectors in this variable. Okay, to shift enter, and the eigenvalues must be stored in this value. So if I print this out, I can see that a pair of eigenvalues have been calculated for us, which is -6 and -1. And if we want to see the eigenvectors, if we print this out, we are getting a 2 by 2 matrix, and actually it is mapped to the eigenvalues column by column. So -6 is my first eigenvalue. So the first column of the eigenvectors matrix is actually this column and this column together forms the this entry and this entry together forms the column which is an eigenvector corresponding to the eigenvalue -6, and the second column is the eigenvector corresponding to the eigenvalue -1. Okay, so while you are calculating eigenvalues and eigenvectors, it's highly recommended to not do the calculation manually because it's a long calculation and chances are high of making errors. Okay, use some kind of software for this. This is a demo of that we can do this with Python.